Who remembers from, I think it was Friday's lesson, right? What was the reciprocal to sine? If you look back in your notes, what was the reciprocal to sine? Cosecant, right? So one of the identities that we can use is say that the sine of theta is the same thing as 1 over the cosecant of theta, right? Because it's the reciprocal function, so we have 1 over something. So we've got the sine of theta is 1 over the cosecant. Who remembers what the cosine was? Yeah, so that's 1 over the secant of theta. And reciprocal identity, right? 1 over something. And then finally, the tangent function. What was the tangent? 1 over what? 1 over cotangent of theta, right? That's all from Friday, and that's in our little notes, right? So we're just officially identifying these as reciprocal identities. So we can now interchange sine of theta for 1 over cosecant, cosine of theta for 1 over secant, tangent for 1 over cotangent, anytime that we need to when we're trying to understand trig identities, which we will be doing later this week. So let me ask you this. If sine theta is 1 over cosecant theta, what does the cosecant theta have to be? Yeah, pretty straightforward, right? This has to be 1 over the sine theta. And the secant theta has to be 1 over what? Yeah. And then lastly, cotangent has to be what? There you go, right? There you go. These are called the reciprocal identities. They're pretty straightforward. You need to know that they exist and that we can use them when we need to simplify trig identities, which we'll be doing later on. So that part's super important. That's the first major concept, the reciprocal identities for us. Okay. Let's talk about the quotient identity. So what's different here from the reciprocal? People always ask, right? Well, the quotient identities mean that we're going to have something other than 1 up on top on the numerator, all right? And there's only 2 of these. There's the cotangent and there's tangent and cotangent. So I like to introduce this by drawing this little tiny picture over here of this little right triangle. And I have theta in the bottom left-hand corner. So if I asked you, what would the sine, according to my little picture here, what would the sine of theta be defined as according to my little picture? The opposite over the hypotenuse, yes. Okay. What would the cosine of theta be defined as my little picture here? The adjacent over the hypotenuse, right? And then what would the tangent of theta be defined as in my little picture here? Opposite over adjacent. You guys all agree with that part? Yeah. Now here's the connection that few people actually see or make. What would happen if I just took a look at this part right here in the little box and made a giant fraction out of it? The hypots cancel out. Very good. What are you left with? Opposite over adjacent, which is exactly what that says. So therefore, the tangent of theta can be written as the sine over cosine. You guys see that? Some people don't see that. You do see it? Oh, you do see it. So the tangent of theta can now be rewritten as the sine over cosine. And that little picture diagram, this is actually like a little algebraic proof here, right? Shows you why the tangent is equal to sine over the cosine in that quotient. So that's one of the quotient identities. Now, take your forward thinking and deductive reasoning here. If the tangent is sine over cosine, what must the cotangent have to be? There you go. Cosine theta over sine theta. You got it. And those are the 2 main quotient identities. So far we have the reciprocal identities, 1 over something. We have the quotient identities, which just involves tangent and cotangent and that little proof there. And then we get into the real main idea, the Pythagorean identities here. You go too fast. Something a little bit more interesting here. These are called the 3 Pythagorean identities, and these look really, really strange when you look at them, but they come from such a simple idea that it's kind of weird how they just all of a sudden appear. So there's 3 of them. I'm going to do 2 of them with you, and then the third one you're going to derive all by yourselves after you figure out what the pattern is. So I have a little picture over here, right? It's a right triangle because the little square says so, and I have A, B, and C all written down together. Okay. So according to my picture, anybody shout it out. What will the sine of theta have to be according to my picture? B over C. No. Oh, sorry. B over C. Yeah, thank you. What would the cosine of theta have to be according to my picture? A over C. And what would the tangent have to be according to my picture? B over A. Good. I want you to just keep that in the back of your minds for just 1 second. I'm going to put it up to there. All right? Now, I'm going to derive the first Pythagorean identity with you. And I'm going to start with, of course, the Pythagorean theorem. Have we done anything crazy and magical so far? Nope. Pretty straightforward, right? Now, watch this. I'm going to divide each of my terms by c squared. And let's figure out what this does for me here. First of all, on the right-hand side of my little equation there, what is c squared over c squared? So that's just 1. That's pretty straightforward. Now I have b squared over c squared. Let me ask you a question. Is that the same thing as doing this? B over c squared? Yeah, right? Because I'm just basically raising each term inside my parentheses to a power of 2. So I can go in the reverse order and write it like that. And I can do the same exact algebraic trick for this, right? You guys with me? All right, cool. Who sees it? What is it, Daniel?
That one's cosine plus cosine squared plus sine squared.
Dude, you just figured it out. There it is. Cosine squared theta plus sine squared theta equals 1. What? Check this out. You guys told me that a over c was just cosine, and we're squaring it. And then you also told me that b over c was just sine, and we're squaring that. So, oh my gosh, here is the most amazing Pythagorean trig identity that we have ever seen in our lives. That's a great question. What do you do with that? No one knows. It's a mystery. Thanks a lot. Okay, number 2. All right, number 2. Again, I'm going to start with a squared plus b squared equals c squared. And this time, I'm going to divide everything by a squared. No fool in this crowd. So what's a squared over a squared? Yeah, so this is a big giant 1 plus, same algebraic trick, b over a squared equals c over a quantity squared. Okay. 1 plus, what's b over a? Tangent. So tangent squared theta has to be, what's c over a? I don't have a c over a, dang it. Yeah, but notice that c over a is the reciprocal of cosine, and we know that the reciprocal of cosine is secant, so, oh yes, this is secant squared of theta. Dude, isn't it, I mean, it's kind of crazy that all these come from just a little tiny cheesy picture of a triangle. I think that's amazing. All right, now, ladies and gentlemen, you are on your own for the third one. Okay, trig identities here. Make sure you got these in your arsenal, right? It's right there, this one, this one, this one, and if you can, memorize those if you can. They're not that bad. So that would be a great thing for you to do. All right, let me